Hello, and welcome back to another installment of the Make Math Make Sense series or the Math Made Easy series. And in this video, we are going to be touching upon the idea behind integration. And integration is one of those things where I always find people get caught up in the weeds of integration. And let's say they have like something difficult or complicated, like a triple integral or they have to like integrate by parts or something. And they always get caught up in the weeds of integration, and they have these huge um, pages upon pages of like trying to solve this one problem, and they forget about why they're even doing it in the first place, and the idea behind integration in the first place. So that's what I'm going to talk about today. And as always, we start off simply with things that you should already know and be familiar with, and then we build upon that from there. Um, so basically, the idea behind integration is that we're trying to find the area under a curve, the area under the curve. And so basically, we already know how to calculate area. We already have shapes like rectangles and squares and circles. And we know how to calculate the areas of these already. So they're length times width, and then pi r squared. And curve just means, instead of seeing like a straight line, you're going to see like something like that, or maybe a parabola, something parabolic. But integration will work with all of these regardless of what shape it actually is. So let's work with an example right here. Let's say that we have a function f of x equals x. Okay, nice and easy. So basically, the idea, I want to integrate this and then I can graph it out so you can see it visually. So basically, how we're going to integrate this is we're going to use the formula x to the power of n plus 1 over n plus 1. Uh, and so basically, here you can imagine that there's uh, in the exponent spot a 1 here, like an imaginary 1. And so if we're going to integrate this, um, we're going to integrate the function x with respect to dx. Well, x dx. So basically, this just says integrate x with respect to x. Um, and so how we're going to do it is we're going to, yeah, we're just going to integrate it. And we're going to do, okay, so this is going to be x squared over 2. Basically, because 1 plus 1 equals 2. And then we have to put the 2 to the bottom. And then we have to finish it off with a plus c. And we have to finish it off with a plus c because we don't know the intervals in which we are finding the area for. Usually you would see, let's say, there'd be some numbers here, like 0 or 1 above here. And they're going to tell you the intervals of x in which you are going to find the area. But since we don't know what intervals we're using, uh, we have to put a c there because we don't know. But in this case, I'm going to put an example here, and I'm going to say that we are finding the area under the curve from the interval of 0 to 2. And so we're going to integrate this again, x with respect to dx. And basically, what it's going to equal is, well, we already have x squared over 2, but now we just have to plug it in, okay? And so basically, it's going to be 2 squared over 2 minus, and then we plug in the 0. 0 squared over 2. And this should be pretty self-explanatory because, we're just plugging in the numbers for x and solving for that. Okay, so 2 squared over 2 is 4, divided by 2 is 2, and 2 minus 0 is 2. And so basically, we are basically saying here that the value for the area under the curve of this given function is 2. And I really want to write this out. I really want to graph this out so you guys can see it visually, to just see that like this actually works, and really get like a visual representation of this. So let's say we have 1, 2. And let's say I have 1, 2. So basically, um, the function, if we plug in 0 for x, then we get 0. If we plug in 1 for x, then we get 1 as y. And we get 2 out when we plug into. So we have our function right here, and we can kind of see that it looks like a triangle. So we have to find the base and the length of it, because we know how to calculate the area of a triangle. It's length times width divided by 2, and now we just have to find that length and that width. So basically, the intervals here are 2. It's 2 because 0, 1, 2, which means the length is 2, and also the height is 2 because well, that's the function, so it's because obviously if we plug in 2 for x, then we're going to get 2 for y, so the length here is 2. And so now we have all the things we need for our formula. So as we said, the area for a triangle is length times width divided by 2. And so if we plug that in, then we get 2 times 2 divided by 2, and that equals 2. And now as you can see, we also got the value of 2 when we integrated it. And we have a visual, now we can see from this visual representation that it's also 2 on the graph, and we just graphed it out. So we have just proven by example that we can use the process of integration in order to find the area under the curve. All right, so that was the video. If you guys found it useful, please give it a like, comment, and subscribe to the channel if you want more mathematically related content. Thanks and have a good day.